dive into assembling the computer. Welcome to IT Essentials 8. In this chapter, we're diving into PC assembly, the nuts and bolts of putting a computer together. Whether you're new to this or just need a refresher, we'll cover the key steps and components to get you building with confidence. Let's get started. In this section, we're diving into the hands-on process of assembling a computer from the ground up. We'll start by defining important safety standards, both general and fire-related, to keep everything secure. Then, we'll connect the power supply and install the motherboard components. After that, we'll move on to adding internal drives and adapter cards. We'll also identify extra storage options and make sure all the components are connected properly with the right cables. This chapter lays the foundation for building a fully functional system. Now let's dive into assembling the computer. This step is all about bringing together the key parts, the processor, memory, storage, and more, to build a functioning machine. It's where all the components meet and start working as one piece connects just right. It's a crucial phase that sets the foundation for everything that follows. In this video, we're focusing on general and fire safety precautions when working with computers. First, it's important to remove watches or jewelry to avoid accidents. Always turn off and unplug equipment before starting. Keep your workspace clear of clutter and cover any sharp edges inside the computer. Wearing safety goggles protects your eyes. Use proper lifting techniques to avoid injury. Finally, know where the fire extinguisher is, understand its rating, and how to use it if needed. Safety comes first. Now we're moving into a practical demonstration, how to install the power supply. First, we open the computer case to get access inside. Next, we carefully align the screw holes on the power supply with the mounting points in the case. Finally, we secure the power supply by screwing it firmly into place. This video will walk us through these steps clearly, making the process easy to follow. Let's see how it's done. When building a computer, the motherboard and external components really set the tone for everything else, especially the case and power supply. The motherboard's form factor dictates the type of case you'll need, so size and shape have to line up perfectly. Then, there's airflow to consider. More components mean you'll want extra space for cooling. Power supply ratings and connections must match the motherboard, too. Beyond function, cases come in all sorts of designs, with status LEDs and vents that help keep things running smooth. When setting up case fans, the goal is simple: bring cool air volts, and power supplies are rated by wattage. It's important to pick one that not only powers what you have now, but also leaves room for future upgrades. Otherwise, you might find yourself swapping it out sooner than you want. Next, we'll open the case and connect the power supply. In this lab, we're going to install a power supply inside a computer case. First, we'll open up the case to get access to the interior. Then, we'll carefully connect the power supply, making sure it's secure and properly linked to the components. This step is essential. Without a power supply, the computer can't run. By the end of this lab, you'll have hands-on experience with this crucial part of building or repairing a PC. Let's get started. Now we're moving into a hands-on demonstration, installing the CPU onto the motherboard. First, we align the CPU carefully with its slot. Then we press it down gently but firmly. Next, we lock it in place to secure the connection. After that, we apply thermal paste. This helps with heat transfer. Then, we install the heatsink, followed by securing it tightly. This step-by-step process is crucial for a stable and efficient build. Now, we're moving into a hands-on demonstration, installing the RAM. First, you open the levers on the RAM slots. Then, you line up the RAM chip with the slot on the motherboard. Next, lower the chip carefully into place. Finally, press down firmly until it locks in securely. This step-by-step process is key to making sure your motherboard components are installed correctly and ready to go. Now, we're moving into a hands-on demonstration, installing the motherboard. We start by aligning the motherboard in the right direction, making sure everything matches up. Next, we find and install the standoffs inside the computer case. These keep the motherboard elevated and safe. Then, we align the I/O plate at the back of the case. Finally, we lower the motherboard into place and secure it by screwing into the standoffs. This step-by-step process sets the foundation for building the rest of the system. When choosing a replacement motherboard, there are several key factors to keep in mind. First, it needs to support your CPU and RAM, along with any video or other adapter cards you plan to use. The socket and chipset must be compatible with your processor. If you're reusing the CPU's heatsink and fan, those need to fit as well. Expansion slots should match your existing cards and leave room for future upgrades. Power supply connections must line up. And finally, the new motherboard has to fit inside your current computer. Before you buy a CPU, it's crucial to check that it works with your current motherboard. Compatibility isn't always obvious, so manufacturers' websites are a great place to start your research. They'll have detailed info on which CPUs fit which sockets. On this slide, you'll find tables listing Intel and AMD sockets alongside the processors they support. This helps you make an informed choice before moving on to installing the motherboard components, including the CPU and its cooling system. Let's talk about what really limits how fast a modern processor can run. We measure processor speed in gigahertz, that's billions of cycles per second. But two main factors hold that speed back. First, transmission delay. Inside the chip, data has to travel through tiny wires and transistors, which takes time. Second, heat. Every time a transistor switches on or off, it generates heat. The faster the processor runs, the hotter it gets, and too much heat causes errors. Now, the frontside bus, or FSB, connects the CPU to other parts like memory and expansion cards. It carries data both ways and runs at a frequency measured in megahertz. The CPU's speed is a multiple of the FSB's speed. For example, a 3200 MHz processor might have a 400 MHz FSB, meaning it runs 8 times faster than the bus. Finally, processors come as 32-bit or 64-bit, which affects how many instructions they can handle at once. This all shapes how we choose and install the right CPU and cooling system on the motherboard. When it comes to choosing a CPU cooling system, we're dealing with one of the most critical parts inside the computer, the CPU itself. It's expensive, sensitive, and it heats up fast. To keep it running smoothly, we usually rely on either air cooling or liquid cooling, both paired with a fan to dissipate heat effectively. This slide points out key factors to think about when picking the right cooling solution for your build. It's all about protecting that vital component. Sometimes, when an application freezes or your computer shows frequent error messages, it could be a sign that you need new RAM. To check, you can run a RAM test right from the BIOS. But remember, the new RAM's speed has to be compatible with your motherboard's chipset. RAM comes in two types, unbuffered and buffered. Unbuffered is the regular kind, faster because the computer reads data directly. Buffered memory, on the other hand, is designed for servers and high-end workstations, with a controlled chip to help manage large amounts of RAM efficiently. In this lab, we're going to get hands-on with some core computer components. First, we'll install the CPU, followed by the heatsink and fan assembly to keep it cool. Then, we'll add the RAM modules to the motherboard. Once all these parts are in place, we'll secure the motherboard inside the computer case. This step-by-step process helps us understand how these pieces fit together to build a functioning system. Let's dive in and get started. Now, we're looking at a video demonstration that walks us through installing internal drives, both hard drives and optical drives. For the hard drive, we start by aligning it with the drive bay, making sure the connectors face the motherboard. Then, we slide it in and line up the screw holes before securing it with screws. The optical drive installation is similar. We pick the right bay, remove any faceplate if needed, position the drive, and screw it in place. It's a straightforward process that keeps everything secure and connected. Sometimes, you'll need to replace an internal storage device, either because it's failing or it no longer fits your customer's needs. Signs of failure include strange noises, unusual vibrations, error messages, or corrupted data. Internal drives usually connect to the motherboard via SATA, while external drives use USB, eSATA, or Thunderbolt. Older motherboards might only support IDE or eIDE. So, when choosing a hard drive, compatibility with your motherboard's interfaces is key. Most internal hard drives come in a 3.5-inch size, but 2.5-inch drives and SSDs are growing in popularity. When we're choosing a new hard disk drive, there are several key factors to keep in mind. This slide breaks down the main considerations, things like capacity, speed, and reliability. We also need to think about compatibility with our system and the type of data we'll be storing. Each factor plays a role in making sure the drive meets our needs, both now and down the road. Let's keep these in mind as we move forward. When we're choosing an optical drive, there are a few key factors to keep in mind. This slide points us to the main capabilities we should consider, things like read and write speeds, supported formats, and compatibility with our system. It also touches on how to install internal drives and select the right optical drive for our needs. Understanding these points helps us make a smart, informed choice. When installing a hard drive, the first step is to find an empty drive bay in your computer case that fits the width of the drive. If you're adding multiple drives, it's best to leave some space between them. This gap helps with airflow and keeps things cool. Also, make sure to mount the drive with the metal side facing up. That metal surface helps dissipate heat. The case holds drives in these bays, and there are 3 common types you'll usually encounter. Here's a handy installation tip. Start by hand tightening all the screws just a little before you use the screwdriver. This simple step makes it much easier to tighten the last couple of screws without any struggle. It keeps everything aligned and saves you from fighting with stubborn screws at the end. Let's keep that in mind as we continue installing the hard drive. Let's start by choosing the drive bay at the front of the case where you want to install your optical drive. If there's a faceplate covering that bay, go ahead and remove it. Next, line up the optical drive with the 5.25-inch opening. Make sure the screw holes on the drive match those on the case. Slide the drive in carefully, then secure it with screws. A quick tip: hand tighten all screws first, then go back and fully tighten them. This makes the process smoother. Now we're moving into the hands-on part of the lab. Here, you'll be installing both the hard disk and the optical drives inside the computer. This step is crucial. It's where the components start coming together to form a working system. We'll cover the proper way to secure these drives, connect the cables, and ensure everything fits just right. Let's get ready to install the drives and bring the machine to life. Now, let's walk through installing the adapter cards step by step. First, we find an empty PCIe X16 slot in the case and remove the small metal cover blocking it. Next, we carefully align the video adapter card with the matching expansion slot on the motherboard. Then, we press down gently until the card is fully seated. Finally, we secure the card's mounting bracket to the case using the correct screw. This process ensures a solid, stable connection for your video adapter. Adapter cards are specialized components that add extra features to a computer, like better graphics, sound, or storage control. They fit into expansion slots on the motherboard, which come in 2 main types, PCI and PCI Express or PCIe. PCIe slots vary in size: X1, X4, X8, and X16, each designed for different bandwidth needs. If your motherboard lacks the right slot, you might consider an external device instead. This slide helps us understand how to choose and install these cards properly. When it comes to choosing adapter cards, there are several key factors we need to keep in mind. For graphics cards, we look at the slot type, how much and how fast the video RAM is, the GPU itself, and the maximum resolution it supports. Sound cards require us to consider the slot type, the digital signal processor, connection options, and signal-to-noise ratio. Storage controller cards bring their own checklist: slot type, connector count, whether connectors are internal or external, card size, onboard RAM and processor, and RAID capabilities. Before buying any adapter card, we have to ask, what does the user need now, and what might they need down the road? Is there a compatible slot open? And what configuration options do we have? These questions help us make smart, future-proof choices. When it comes to choosing the right adapter card, there are several factors we need to keep in mind. First, think about the user's current needs and what they might need down the line. Next, check if there's an open expansion slot that fits the card. Then, consider the card's specifics, like slot type, speed, and power requirements for network cards, or storage and resolution for capture cards. It's about matching the card to the system and the user, so everything works smoothly together. When we install expansion cards, they slide into the right slot on the motherboard. Video cards often need extra power, usually through a 6-pin or 8-pin connector from the power supply. Here's a tip: always check the length of your video card first. Some longer cards won't fit certain motherboards. Also, mounting brackets can come in different heights to help with this. And one more thing, some cases have small slots at the bottom of the opening. Sliding the bracket's bottom into that slot makes installation easier and more secure. In this lab, we're going to get hands-on with some essential hardware. You'll install a network interface card, or NIC, which connects a computer to a network. Then, you'll add a wireless NIC to enable wireless communication. Finally, you'll install a video adapter card, which handles the display output. This practical exercise gives you a solid foundation in upgrading and expanding a computer's capabilities. Let's dive in and get those cards installed. Over the years, several types of media cards have come and gone. You've got secure digital, or SD cards, along with their smaller cousins, microSD and mini SD. Then there's compact flash, memory stick, and XD cards. Each has its own purpose and compatibility. When picking a media reader, think about what you need now and what you might need down the road. Choosing the right reader means smoother access and more flexibility with your storage options. External USB flash drives, often called thumb drives, are a popular choice for removable storage. They connect through ports like USB, eSATA, or Thunderbolt. When helping your customer pick external storage, think about their needs. For small tasks like moving a single presentation, a flash drive works well. But if they need to back up or transfer lots of data, an external hard drive is a better fit. It's all about matching the right tool to the job. Now, let's walk through connecting the internal power cables. First, we align the 24-pin ATX power connector with its socket on the motherboard. Then, press down gently until you hear that satisfying click. That means it's locked in place. Next, we do the same with the 4-pin auxiliary power connector, lining it up carefully and pressing until it clicks. Finally, we connect the CPU fan power cable, again making sure it's aligned and clicked securely. It's all about careful alignment and gentle pressure. Now we're moving into a hands-on demonstration, connecting the internal data cables. First, we align one end of the SATA cable with the motherboard socket, making sure it fits snugly. Next, we take the other end of that same cable and connect it to the smaller SATA port on the drive. This video walks us through those steps clearly, showing how these connections bring everything together inside the system. Let's see it in action. In this part of the lab, we're focusing on installing the internal power and data cables inside the computer. It's a crucial step. These cables connect all the components, making sure everything gets the power it needs and can communicate properly. We'll take it slow, making sure each cable is routed neatly and securely. This hands-on work helps us understand how the computer's parts come together to function as a whole. Let's get started. Now, let's walk through connecting the front panel cables step by step. First, we plug the power cable into the spot labeled PWRSW. Next, the reset cable goes into reset. Then, the power LED cable fits into PWR LED, and the drive activity LED into HDD LED. After that, the speaker cable connects to speaker. Finally, we plug the USB and audio cables into their respective connectors. This video demonstration makes the process clear and straightforward. Let's talk about the system panel connector, a key part of any computer build. On the front of your case, you'll find the power button and those little activity lights. They're connected by cables that run inside the case. These cables all plug into a single spot on the motherboard called the system panel connector. The motherboard usually has labels nearby, so you know exactly where each cable goes. Connecting these properly is essential to getting your system up and running. Let's talk about system panel connectors, those small but essential links between your motherboard and the front panel of your computer case. They include the power button, reset button, power LED, drive activity LEDs, system speaker, and audio connections. These connectors aren't keyed, so they don't have a fixed shape to guide you. Instead, each cable usually has a small arrow pointing to pin 1. On the motherboard, pin 1 is often marked with a plus sign for the LED pairs. This helps make sure everything goes in the right place. When we look inside new cases and motherboards, USB 3 or 3.1 ports are common. The cables that connect to these ports usually have 9 or 10 pins, arranged in 2 rows. This setup lets us have 2 USB connections from one cable. Often, these connectors come paired together, sometimes even joined as a single piece, making it easier to plug into the motherboard's USB connector. This slide shows how these internal USB connections fit into the bigger picture of installing front panel cables. Now, let's talk about connecting the front panel cables, those little wires that link your case buttons and lights to the motherboard. For each connection, it's crucial to align pin 1 on the cable with pin 1 on the motherboard header. This applies to the power button, reset button, power LED, drive activity LED, and system speaker. USB cables follow the same rule. Audio cables are a bit trickier, though they can vary a lot, so always check the manuals for your specific hardware before plugging anything in. If a button or LED on your front panel isn't working, it's usually because the connector is plugged in the wrong way. The fix is simple: shut down your computer, unplug it, open the case, and flip the connector around. To make this easier, some manufacturers provide a keyed pin extender that combines several cables into one, preventing mistakes. Here's a handy tip: these connectors are tiny, so take a picture to find pin 1. And if space is tight, a part retriever tool can help you plug everything in smoothly. Now we're moving into the hands-on part of the lab. This is where you'll install the front panel cables inside the computer. These cables connect important buttons and indicators, like power, reset, and LEDs, to the motherboard. It's a crucial step that brings the system to life. Let's focus on getting these cables properly connected, so everything works smoothly when we power up. Now we're walking through the final steps of putting the computer together. First, if needed, reattach the front panel. Then, plug the power cable into the power supply. That's the lifeline for the whole system. Next, connect the USB cables, making sure they're oriented correctly. Follow that by hooking up the video cable to the video adapter, and don't forget to tighten those screws. After that, connect the network and audio cables. Finally, slide the side panel cover back on and secure it with screws. That's how we finish the assembly. Now we're moving into the hands-on part of the lab. This is where you'll install the side panels and connect the external cables on the computer. It's the final step in putting everything together. Once you've completed this, the computer assembly will be finished and ready for testing. Let's make sure all the connections are secure and the panels fit just right. Let's take a moment to wrap up what we've covered in this chapter. We've explored key ideas and laid the groundwork for what comes next. This summary highlights the main points, making sure we're all on the same page before moving forward. It's a quick checkpoint, a chance to reflect on what's important and how it fits into the bigger picture. In this chapter, we walked through the essential steps to build a computer from the ground up. We started by defining general and fire safety standards, because safety always comes first. Then, we